Guys, in this video we'll be having a look at operator overloading. So here I have taken an example of Apache Airflow, which implements a DAG, which is directed acyclic graph. So let's suppose your first task it is connected to second and the third task, and the third task has to be third task begins only after the completion of the fourth task. So it's kind of a directed graph kind of thing, and it uses this right shift and left shift operators. So probably they're using operator overloading on these objects. So how can we do this kind of thing, fancy thing, in Python? So this thing can be so let's suppose I have node 1. The node 1 is connected to node 2, and node 2 is connected to node 3, 4 and 5. So I will have to write like this. So how can I design and implement this kind of functionality in Python? So let's suppose I have a class node, and now in the constructor, let's suppose I take in a data, like each node is having its own data, and now I will be storing the children which are connected to this node as a list. So this is my data structure of the node. Now I want to do a operator overloading on this class. So I will do a dunder R shift to overload this operator. So dunder R shift self, and it takes a parameter. So let's suppose I have a node, and then I want this right shift, and then there's an item. So this item goes into this parameter in this R shift function. So let's suppose I have an item, and as we saw in this thing, this item can be a list or it can be a single node. So we have to identify what kind of object is item. So I will use isInstance if this item is an instance of node. Then I will just do self.next.append, and I will just simply put the item. And now if this item is an instance of list, and I'm also doing an assertion that all of the items in the list has to be the instance of node. So I will do it like all of like for it in items, and I can have is instance of it commando. So it will just assert that all of the items are of the type node. So now I'll just do a for loop, and I'll just say self.next.append, and it. Okay. Else I'll just raise an exception that this data type is not allowed. And now I will just return. So let's suppose I do this kind of operation, and after this operation it has to return return something. So after that it should be returning this item, because after that if I do another operator overloading, this item 2 should be connected to this item. So I am doing this, so I should return item in this case. Now we'll see another case in which I am having a list. Let's suppose I'm having a list and I have n1 and 2 and this follows an item. So in this case I can't do operator overloading on a native Python list, because I can't modify inbuilt classes provided by the Python. So I will do something which is known as reverse R shift, which is double R shift, and in this case it will see that if for this item, if it is of the type node, then it will consider this thing as its argument. So over here I'm having this item, and now I have to assure that this thing has to be a list, and now I can just do it like this. I'm just appending it, and else I will just raise an exception that this thing is not allowed. And lastly I'll just return the self. Why self? Because this thing is a self and this thing is an item over here. So I will be returning the right operator in this expression, because Python evaluates from left to right, so I have to return the right most thing. Over here in this thing, this expression should return item 2, because if I do an operation again on this expression, it should return and it should act upon item 2, so always the right thing. Okay, so now we'll be instantiating some nodes. I suppose I have the node 1 and I have some children, which is child I for I in range. Let's suppose I have 5 children, and now I have a merge node which will merge these children. So I have merge. Now I will do node 1 and then I have children, I have merge. Now we can check that this thing runs without error. So how do we know that which function is called when? So on the first call of this thing, this function is being called. I can prove it to you, like right shift is called, and if I just compile this, I'll get this. And now if I do it like this, merge, so this thing has to be called. Double R shift is called. Okay, so over here double R shift is called, and if I do it like this, I'll say R shift is called and double R shift is called. So in this way you can implement these kind of fancy looking syntax, and which is much more simpler to use, rather than I have to every time to say add child and then I'm doing this kind of boring stuff. But this is kind of fancy and it looks pretty much cool. So thank you guys for watching this video. Hope you guys learned something new. From this